welcome back, everybody, whether online or otherwise. Hopefully, you didn't get hit too bad by the hurricanes, rather. So, let's see. So it's been a week. So let me catch everyone up. So, of course, there was not anything due over the hurricane break, because all the classes were canceled. There weren't any remote classes. There was nothing. It was just everything was canceled for that week. So everything got pushed back. The first assignment that's due, provided you already did the upload assignment, first assignment due is tonight. Yes, tonight. It's on the stuff that we're going to finish today in class. We only have one or two more concepts, and really they're the more tame. So that's why I recommended everyone finish everything around it. So that way you can knock out those really quickly. So that's due tonight, and then the quiz is due tomorrow if you have not done that already. So homework tonight, quiz tomorrow. If you did what I recommended about the homework, then you shouldn't have but maybe like 3 or 4 more problems. And I promise they should be easier. So with that out of the way, so yeah, just as a reminder, it's this assignment that's due tonight, and the quiz is due tomorrow. So fantastic. Let's go ahead and pick back up where we left off. And I'm actually going to, in one class, I think I went further in this class than my other class. I wanted to just go over this diagram again really quickly. We might have went through it already. I'm just going to go through it again. So if you're already good with this stuff, you could just kind of tap out for a few minutes. Shouldn't take too long. So. All right, cool. So we were talking about how to determine even, odd, or not that. Well, that's one of the characteristics here. We have this W function, and we're just going to figure out some various properties of it given the graph. And so, again, we might have went over most of this, if not all of this last time. The x-intercepts, we'll go ahead and just start there. X-intercepts, any place the graph crosses the x-axis. As we see, we have 2 spots here and here. We need to represent those as ordered pairs. So we said -1, 0, and 1, 0. So some of this should be review. Y-intercept, that's where the graph crosses the y-axis. It only happens once here, and that seems to be 0, 2. Where's the eraser at? There it is. Cool. Domain, this might be a little bit better to reference right quick. The domain, x values, referring to left and right. The furthest to the left this graph goes is right here, which has an x value of -3. That point is included, so we use a bracket. And then the rightmost point will conclude our domain, and that has an x point of 3. Which also has a bracket. Range is lowest to highest. So the lowest point seems to be shared between these 2 points. The y value of this is 0. And that is included with a bracket. Highest point seems to be these 2. What is the y value of those 2 points? 3. This was the idea we talked about before. Increasing, decreasing, constant. Well, constant implies a straight horizontal line, which we definitely do not see on this blue curve. So if anything, constant is none. Increasing is any place where the graph has a positive slope. It goes in an upwards orientation. I know it's all flipped for you all as opposed to me, so hopefully I'm doing that in the right the right way. It's a lot easier to do that in person. So increasing, that would be characterized by, say, this segment and this segment that I just highlighted in black, because those are where the graph is increasing, going upwards. Think about it as a roller coaster. So it's the same idea. Increasing, we use X values to represent where it starts and stops. We never use brackets. Never use brackets for increasing, decreasing constant, ever. So for this segment here, it starts at -1, ends at 0, because we use the X values. -1 to 0. We also do not use unions for increasing, decreasing, or constant. We just use commas. Why is that the case? It's because we're looking for intervals, plural. So that first increasing interval denotes this first segment that I highlighted, and now the second segment, where it starts at, I'm drawing a 1 right here. That's the X value for which the segment starts at, and then where it ends at seems to be 3. For that one, it just so happens that X and Y are both 3, but I'm using the X value. Decreasing. So if that was a little bit fuzzy for you, increasing was that, and decreasing is almost the same exact logic. So I'm going to pretty much go through it again, but from a different perspective. And I'll use red. So for decreasing, that's everything, of course, going downwards in a downwards trend. I'll highlight it in red. So that would be here and here. So this first segment that we have going downwards, that will be denoted by, well, again, the X values. Where does this red segment start as an X value? -3. And that's because of this point right here. Where does it end at? It ends right here, which is -1. Second segment, which X value does the second segment begin at? It's at 0, ends at +1. And constant was none. Finally, the symmetry. By this point, we should establish the terminology of even, odd, or neither. Even is symmetry with respect to the y-axis. So y-axis forms a mirror. And it seems exactly symmetric in that case here. This is a perfect W. Everything on the left-hand side of the y-axis is happening simultaneously on the right-hand side. So we would say this is even. Pretty Saints fan. I'm sorry I'm using Falcons colors. I apologize for that. So we might have talked about this already. If not, here's another slightly more abridged characterization of everything. In-class people, okay for now. Check on my meet people. Morning, good morning. All right, all right, cool. So I'm gonna go ahead and erase this. I hope you all remember the drill by now. I was given a tablet, another tablet that has a much better writing apparatus with it, but they didn't give me the right cord. This cord does not go into it for my in-class people. So I gotta go back and complain. It works better than this though. So hopefully I should have that implemented by Wednesday. So this was the stuff I wanted to go ahead and jump through. So, so even, odd, and neither. So we determined what these mean given a graph. And so there's also naturally in the section, we compare graphs and algebra. Graph is the geometry, algebra is function notation. There's a natural correlation between the two. One is a visual representation of the other. And so naturally, for symmetry, we can figure out symmetry even if we're not given a graph. So I did detail the criteria up on the beginning, up at the beginning of the property of functions section. And it has this weird notation to it. I promise it's a lot nicer than this in practice. This looks a little funky. So let me explain what this means. So even if this thing happens odd, and then there's an extra negative sign, let me explain what all that means. So for example 2 here, determine algebraically whether, so all this, you're virtually determining symmetry, but you don't have a graph. So you might think, are we doomed? Not necessarily. We can use the algebraic representations. So to determine even, so to determine if a function is even, I swear that says even, you have to replace every x with a negative x. And I'm going to explain that. I'm going to write that out right here. It's the -2. So I'm writing the function above directly down. But I see an x. Well, I'm going to replace that x. So I'm going to open up a parenthesis. I'm going to put a negative x in its place. I'm going to close that parenthesis. And then I'm going to write everything down until I see another x. I noticed a lot of you got these questions right because they are multiple choice. So I know a lot of you click through really quickly. And so this is the way for which you actually do these, because I would have probably done the same thing. So notice I replaced every x with a negative x, and I used parentheses. So I rewrote the function right above and did that. And now I'm going to simplify as much as I can. So at negative x to the third, let's see, that negative x to the third right here with the -2, that simplifies to 2x cubed. And you might think, how in the world did that simplify to 2x cubed? That negative near the x, well, that negative had a power of 3. Would a power of 3 cancel out a negative sign? No. Power of 2 would have. Because think about it, -1 times -1 times -1. It's just -1. So that negative near the x got to come out to the outside where it joined that negative with the 2. There's 2 negatives. So in other words, the 2 negative signs canceled out. And that's why we have positive 2x cubed. Over, if we go a little bit further to the right, we will see the -9 parentheses negative x. And that negative, kind of the same logic. Negative x has a power of 1. So nothing really happens. So then we get plus 9x. Because again, those 2 negative signs cancel out. And this is the simplified form. In other words, we put it into what's called polynomial form. We'll talk more about that in the next chapter. But we did all this to determine if something's even. Now, what's the conclusion? So what does that mean? So to determine if something's even or odd, so if it's even, that simplified form should have brought us right back to the original function they gave us at the very beginning. So the question is, is this the same thing as this? The answer is no, because obviously there's a bunch of negative signs in the original one, and there's not any negative signs in our simplified form. So your answer would be not even. Well, for that part, because they're still odd. You might think, come on, what more do we have to do here? So now we need to determine if something is odd or not. So what do you do with odd? Well, if you already figured out even, then odd requires one more step. Flip all the signs and then try again. So when I say flip all the signs, it means take that result that you just got for the even and flip every single sign. So what I'm doing, I'm taking this result right here. See, this is why you do even first. You take that result I just boxed in red from the even part, flip all the signs. Or what you're ultimately doing is you're multiplying it by -1. So that's why it comes out to flip all the signs. And then you ask the same question. Is the new result that we obtained, is the new result we just obtained the same as the original function we started off with? Yes. It is. So this is odd. So it is odd. If there's a fraction, you only flip the signs of the numerator. I'm trying to remember if there's any homework questions that have fractions. But in general, so ultimately what you're doing is you're distributing a -1 and then asking the same question. So this would be odd. That would be your conclusion to this. Let me do the next two, and then I'll ask any questions after that. So with problem 2 here, there's an absolute value sign, which pretty much means whatever happens in the absolute value, if it's negative, make it positive. That's all it means. And I'll even show that moving forward here. So let's start off with even again. We're going to replace every x with a -x. And we're going to simplify. So I replaced every x with a -x using parentheses for every replacement, and I'm going to simplify accordingly. This would be the simplified result. The -9 of -x, the negatives cancel, and you just get positive 9x. Inside of the absolute value bars, we have -2 times -x. Well, guess what? That's positive 2x. So that's how we get this final answer. And we ask ourselves, is that final answer the same as the function we started off with? The answer is no, it's not. This is not even. We ask the same question by what ultimately amounts to flipping the signs. can't stand this thing.
It looks like it says ooh.
Yeah, I don't even, I swear that says odd, not ooh. It doesn't say. So for odd, you flip all the signs and try again. Negative 9x minus absolute value of 2x. So is that the same as the original? It looks like it, almost, but it's not. So the negative sign is on the outside. So there was a plus absolute value, and here we have a minus absolute value. So this is not odd. So it would be neither. That's what you would conclude. Then by time constraints, I'm just going to say this one's even. And I think you have the sufficient tools to determine that on your own. But I do need to move on to the minimum and maximum stuff.
The exponent's a dead giveaway, in a sense.
I get asked this question every semester. And there is one caveat to it. So exponents are, with the exception of, so I think you can notice by now that odd has odd exponents, even has even exponents. There is a slight issue. So if you were to say, I'm trying to remember, there's one example I give.
Don't worry about it.
So 8 also has an even exponent because 8 has x to the 0 on it, and 0 is an even number. I think that's the one exception to make. Oh, I remember the example now. X to the third minus 8. Is that even, odd, or neither? You would be tempted to say odd because you only see one odd exponent, but 8 here has 8x to the 0, and that's an even term.
Right.
Odd and even makes it neither.
True.
I don't know how many of those come up, but
Yeah.
we're not supposed to encourage patterns, but if you see the pattern, Caitlin, then she used to do that in finite math all the time.
Whatever.
So regardless, in-class people, how you all feel about this? I mean, if you want to use the exponent thing, go for it.
Carefully.
Yeah, and you can't combine those because those bars are kind of just kind of annoying. They don't really go well with anything. But naturally, we're going to go ahead and erase this and move on to probably the easiest stuff in the section, which is put at the very end of the section. So local min and max and absolute min and max, I suppose it's exactly how it sounds. You have a minimum and a maximum. This refers to some sort of definitive placement of a y value in a more explicit sense. And I kind of wrote out the comparison here. A local maximum is a peak of any hill. So if there's some trend that arcs above, then you will have a local max. Similarly, a local minimum is the lowest point of what's called a valley. So basically the lowest point of, say, a cup shape. The contrast between local and absolute may be, as it's implied, local means that there could be more than one, and absolute means a singular representation. So local would be all the either all the peaks or all the lowest points of the valley. Absolute would just be the lowest or the highest, definitively. To sort of illustrate that here, example 3, we're just going to look for a few of them. So here, this graph of all this wonky curvature, and we're going to look for we're going to start off with the local minimums. So we'll just go ahead and identify the local minimums. That's the lowest point of any valley. So that would be 1. This would be 1. It's the lowest point in any cup shape, and that would be 1. That's it. I don't really have any other way of explaining that. And then, again, it's the lowest point of any cup shape. So we have 3 of them, as I've represented here. And what it wants are the x values. So for each one of those points I boxed, we need to find its x value. This one seems to be -10, because I see -10 up here. Class people, it might be a little hard to see. This one's -2, and then this one is 3. So those are the x values. That's all it's wanting. So you would say negative, try that again. That would be -10, -2, and -3, just a list of the x values that correspond to all those lowest points of any valley. And that's it. So local mins are pretty straightforward. Local max, same idea, but it's the peak of any hill. In essence, it's the antithetical thought process. So here's all the peaks. Here, here, and well, that's it. That's all the peaks. And again, part B just wants the x values of those. Seems to be -4 for the first one. Again, it might be a little difficult to see. That does say -4. The next one is 0. So you would just say -4 and 0 as a list. That's why there's a comma. Finally, it alternates the terminology from local to absolutes for the final part. It says find the absolute minimum. It does give the interval, but that doesn't matter. The absolute minimum, well, minimums are the lowest point of any cup shape or valleys, in other words. Absolute minimum would just mean the lowest. So we found 3 of them before. We want the lowest one. So that one's out, that one's out. Lowest one is the remaining one. And then it wants the x value followed by the y value. So that would be -10 for the x value. And the y value seems to be, might be hard to see, -7. It's a little bit difficult to see, but it's -7.
I have a question.
Yes.
So on my math app, sometimes it'll ask, it occurs at, and I think you have to put it in parentheses. You can put your x, y value where it occurs at. Have you ever seen that?
So like how it's here?
Yeah, but it doesn't always ask it like that. It'll ask it, and I think it'll say, maybe put it in an order pair or something of that sort. My question is, do the circles apply to that? So if it's a closed circle, it would be brackets or open circle parentheses, or is there a?
That depends on the context. That may not be a completely absolute response I could give to that. Because open circles, if they throw those your way, they might be specifying a domain and range as opposed to a min or max. So you could be asking 3 questions in one right now, or maybe not.
I have something specific I can show you.
Okay, yeah, show me the specific thing and I can help you out from there.
Okay.
So that's really local minimum, absolute minimum, and then same for the maximums. That's it, it's just identification.
Absolutely.
The absolute maximum, yes, it would be 0. It'd be 0 and then 7, yeah. So I'm surprised we can make that out. So, well, you're welcome for the notes.
Yeah, thank you.
I'm working on the next unit of notes right now.
I appreciate it.
It take a little bit of time. It's kind of fun though. But other than that, in-class people, good. I'll go check on Google Meet people. I appreciate you helping each other in the comments. As you know, I'm still trying to figure out all this, everything with this back and forth stuff. So appreciate it. So let me go ahead and move on. So this concludes this section. And as I said, this homework is due tonight. If you ask me, if you say, Brad, can you please move the assignment back? I will naturally tell you you need to have an excuse of some kind. I cannot accept, I didn't know. I have over 170 students. I get a lot of I didn't knows. This is me telling you, you should know. So please don't give me that excuse. It's due tonight. I do have office hours as well. So I did post my office hours. I have an announcement for it in Moodle. So go check your announcements. I made a separate announcement just called office hours and how to schedule those. And I got that tablet so I can actually write on my screen. So it's actually better, than me just kind of verbally talking about a problem you may be stuck on. So it's more helpful than you think, the office hours. So all that homework due tonight, quizzes due tomorrow. Cool, let's move on to something that may be a lot more familiar, lines and linear functions. So we'll start off with the line. Hopefully everyone in here knows what a line is. And virtually the comparison between lines and linear functions, we're still going off that idea of comparing a function, which by itself may not necessarily have a graph, to a graphical representation, some visual way of seeing and understanding the graph. And so we'll start off with something simple, the definition of a slope. You may be familiar with this from your previous academic institution, you may not. I did provide the formula where the slope is y2 minus y1 over x2 minus x1, which is simultaneously rise over run. You might be able to go through the majority of this section by yourself and recognize a lot of these problems. If so, you might want to just hurry up and knock that out. I'm going to go through some of the stuff anyways. I may move rather quickly through it. We'll see how it goes. Example 1, we'll go ahead and test out this slope formula up here by, for example 1, finding the slope of the line and interpreting the slope. So in essence, a slope represents the sharpness in the change of data for, well, a line in this case. If you have a large positive slope, then you're going to have a really steep incline. You have a really small positive value for a slope, you will not have that much of an incline. So that's what a slope ultimately references. And so we'll look at a slope in 2 ways for this problem. So we're given some line and we're given 2 points on it. Those 2 points that they give us, well, that's great because that represents so x1, y1 as we call it. So the first point, we could say, okay, well, that's the -1, 2 that they gave us. Right here. That's a point. And x2, y2, that could be the other point at the very bottom right, 3, -4. Again, well, the order doesn't matter here between which point is which. The only thing that matters is don't switch x's and y's. So that the -1, 2, do not switch that as 2, -1. It means a completely different thing. But by making that characterization, the slope is y2 minus y1 divided by x2 minus x1. So this would be the formula. I have the formula written right up at the top. It's at the top of the page right now. I'm following that formula directly. So I just plugged in everything. And from here, you just solve the numerator, you solve the denominator. So -4 minus 2 is -6. 6 divided by 3, ultimately 3 plus 1, which is 4. And since you need to simplify, this would be -3/2. And that would be the slope. So that may or may not be reviewed to a lot of you. Another way you could figure out the slope is by utilizing rise over run. I wanted to illustrate that right quick as well. Rise, well, if something rises, rise this way or this way. That's right, this way. So rise naturally refers to a change in, let's get the two next, vertical values. So rise, starting from the left point, let's see. This would be the rise. And then the run would be, well, naturally, a horizontal displacement. It's normally called. So you would just simply count. At rise, how many units do you go? 1, 2, 3, 4, 5, 6. You go down 6 units, so the rise would be -6. The run, how many units do you go? 1, 2, 3, 4. So you get -6/4 again. That's what we got using the formula. This is just a geometric utility for us if you choose to do it as such. This is the versatility of having a geometric figure to be able to utilize. That's how you move that water bottle like 50 times. So rise over run, if we choose to look at it in this geometric fashion, would be, so -6 was the rise, 4 was the run, and again we get -3/2. It's two means to the same end. And that's all the problem's looking for, the slope. So that's what you would say. So hopefully everyone's okay with that. For those of you who are bored and already knew all of this, let's move on to something more intricate. I guess additionally, before I move on, if the x values were equal, so in other words, if the line is horizontal, vertical rather, if the two x values are equal to 2 points, in other words, the line is vertical, then the slope is undefined. The reason why is because the formula says x2 minus x1 in the denominator here. And if those x values are the same, then you will end up having a 0 in the denominator. It's not good. It's not good. So, vertical line has a slope that's undefined. Horizontal line has a slope that's 0. It says it right here under the slope formula, in case you missed that. That might answer a few homework questions right there. So, we move on to talking about the most familiar characterization, formulaic characterization of a line, which is the mx plus b formula, which should be familiar to a lot of you. Here, the m is the slope. Why is it called m? I don't remember, but it's called m traditionally. So the reason why it's called slope-intercept is because it is built off of knowing the slope and the y-intercept. Why is the y-intercept called b? I don't remember. I bet there's a reason though. So, all right, so that's a nice introduction to that formula. If a line is vertical, remember, vertical means that the slope is undefined. So how do you have a slope-intercept form if you don't even have a slope to work with? Well, then it's even easier. So a line is vertical. Then the equation does not follow the slope-intercept form, and it's simply x is equal to whatever x value you find. We'll see that up ahead here shortly. So vertical lines do not have a slope-intercept form because they don't have a slope. So then it has its own little simplified formula. Example 2 here says we're going to graph the line containing the point and conforming to the given slope. And then we're going to figure out the slope-intercept form. So, in other words, we're given a point of -2, -3. Let's go ahead and plot that. I even generously gave you a graph. So, -2, -3 would be right here. It'd be right there. So, to have a slope of 3, remember what rise over run says. Here, the slope is 3, which is the same thing as 3 divided by 1. You might think, okay, well, duh. But the reason why we force it to be a fraction is because the numerator is rise. So we would rise 1, 2, 3, and we would have a run of 1. And a rise of 1 right here. So that second point would be the additional point that we find based off of going up 3, a rise of 3, and a run of 1. And now that we have 2 points, we can successfully draw the line connecting them. So my line's horrible, but you get the idea. That should be a straight line that passes through the 2 given points. Now this line does not really do justice on your end. It will be very much, you just plot 2 points and it will make the line for you. which means you will be able to figure out what the y-intercept is really easily. And you might think, why do I need to know the y-intercept? It's because we need to then determine the slope-intercept form. To determine the slope-intercept form, here's the formula, mx plus b. We need to know the slope and the y-intercept. So I guess looking ahead, I know what the slope is, so let me try and recreate this. What it should do is pass through 3, like that. So that's what the line should more so look like. I'm just doing a horrible job drawing it. But we need the slope, which was given to us already. It's just 3. So 3x, so x is just x, so we just write x. And b is the y-intercept. We talked about a y-intercept before. It's where the graph passes the y-axis. Where does the graph pass the y-axis? Right here at 3. So this would just be plus 3. And that would be our slope-intercept form right there. In class, people, are you with me so far? Am I still lagging for my Google Meet people? Someone could just let me know right fast. Okay, cool. Yeah, I don't know why that was happening. Sorry about that. All right, so let's go back. So we graph the line, which on your end, you will just plot 2 points and the line will be created for you. And then you can use that to determine the slope-intercept form, which we have down here is 3x plus 3. Let's move on to problem 2 over here, where they give us a point of 4, 3. So we can go ahead and plot that. And it says that the slope is undefined. So I mentioned this earlier. An undefined slope means vertical line. That's it. Vertical line means undefined slope. Undefined slope means vertical line. So we don't even have to find a second point. We know that the line is vertical. I can draw that one a lot more easily. And so we need to figure out the slope-intercept form. Now, the issue I said earlier, vertical lines do not have a conventional slope-intercept form because they don't have a slope. The slope, it says, is undefined. So it has its own formula, its own form, which I mentioned above. It's just simply x is equal to whatever the x value is, 4. That's it. This is the convention you would take if you are given a vertical line. And that's it. So that's pretty much it for this problem. Let's go ahead and move on. Now there's something called the point slope form. And I guess a typical question to ask, a very fair question to ask, is why do we need more than one form to represent the same thing? And it's all contingent upon the information provided. Sometimes we're not given, for the previous formula, we can only use that formula if we're given a slope and a y-intercept, hence why it's called the slope-intercept form. But what about if we don't know, say, the intercept? Let's say we know the slope and 1 point. Well, then that's when we use the point-slope formula. If we know a point, and we know the slope. If that's the case, so that's why these formulas are named this way. They're named off of the things that you need to have in order to use it. Slope-intercept, you need to have the slope and the y-intercept. Point-slope, you need to have the slope and a point. Simple as that. And then the corresponding formula, as you see here, yes. It will also say something about you can put your answer in one of these forms or general form. Ignore general form, which is not, you don't have to use general form. I don't feel like talking about it. It's kind of a pain. If you really want to know about it, you can ask me another time. General form works really well with hyperplanes, but we don't talk about those in this class. So example 3, we're going to, well, I just mentioned in this definition, you use this formula when you have a point and the slope. Example 3, well, shoot, all we have is the slope and a point. Oh, wait, that's exactly what we need. That's exactly how this formula works. So it says, find an equation for the line with the given properties. Here's the given properties. For practice, I said express the answer in point-slope form, then express it in slope-intercept. And this is a natural sequence of steps that I'm about to write out. This would be the same exact process as if I were to say, put it in slope-intercept form. And I'll explain why. So you would look at this and you would think, all right, I have a slope and a point. What formula do I use that utilizes a slope and a point? The point-slope formula. So here, what this tells us is that m is equal to -3, and that x1, y1 is equal to, well, -2, 1 respectively. So x1 is -2, y1 is 1. So the formula, I'll just rewrite it. That's the formula. And we're going to plug in the slope, the x1 value, and the y1 value. X and y, just stay x and y. That's how this formula works. So it's now y minus y1. What is y1? y1 is +1. There's already a minus sign in the formula. So we have to adhere to that. The slope is -3. Then we have x minus x1. x1 is -2, so it's x minus -2. This is already point-slope form. So by simply identifying and converting everything over appropriately, this is point-slope form right here. So if it asks for point-slope form, say point-slope form. So that's what PSF, point-slope form. So if it were asking for just that, which it doesn't do often, unfortunately, but if it asks for that form, this is where you would stop. But of course, we need to also continue the problem to express the answer in slope-intercept form, which means ultimately we have to simplify this form. So let's keep going. I'm going to go ahead and simplify this as x plus 2. because we had x minus -2, which is just x plus 2. And then that makes the distribution very clear with the -3. So then we have y minus 1 is equal to -3x minus 6. And we're not done yet because one of the conditions of the slope-intercept form is we need y by itself. We need y just fully isolated. If we look at this form down here at the bottom, there's that -1 in the way. It's kind of lame. We got to get that out of the way. We got to add 1 on both sides to get y by itself. And by completing that final step, so we add 1 on both sides. I'll even write that, +1. We add 1 on both sides. Then we have like terms. And this is the more popular form to put it in. So that's a pretty standard process. You should familiarize yourself with the process if you're given a slope and a point, because generally you will have to go through this to put it in. Most of the time they'll make you put it in slope-intercept form. Pretty much every time, unless they specify point-slope form, which they do not do often, but I just want you to be aware of that. And again, if they say general form, I looked at all the problems. You don't have to use whatever general form is. In class people, you feel? Check on my Google Meets. Cool. Alrighty, I'm gonna go ahead and start mass erasing and let's move on. So we move on. We're going to define intercepts in an algebraic fashion, on how to find them in an algebraic fashion. I've already talked about this or touched on this before. We definitely have already identified x and y intercepts on a graph, simply when the graph crosses the x-axis and the y-axis, respectively. And in fact, that's what I have written as the first part of each definition. The x-intercept is where the graph intersects the x-axis. Y-intercept, same thing. But the generalization is, well, what happens if you don't have a graph to work with? Well, I wrote the conditions for each definition here. The x-intercept can be found by setting y equal to 0 and solving for x. That's the rule. And that's not going to change for the rest of the semester when you see the same type of problem 50 times. So it's going to be the same idea. You're going to be doing this a lot in this class. So you might as well go ahead and highlight this or star this, asterisk, whatever. So that's how you find the x-intercept. You set y equal to 0 and you solve for x. To find the y-intercept, you just flip the process. For y-intercept, you set x equal to 0 and solve for y. So it's always the opposite. Because for the x-intercept, if you set x equal to 0, then you already know the x. And we all know, these problems don't get that easy. but this is a shorthand. And we'll go ahead and look at that here. So they give us this equation here, and they want us to start off by finding the x and y intercepts. We'll go ahead and start off with that. Start off with the x-intercept. And the rule says set y equal to 0. So for that equation that we have up here, we're going to set y equal to 0 and solve for x. So the 3 times 0 in that second term, just 0. So we're left with 2x is equal to 6. And guess what? X is 3. I don't remember if the problem or these types of problems ask for just the x-intercept as a value or an ordered pair. As an ordered, well, as a number, it would just be this. As an ordered pair, it would be, I'll put that up here. 3 is x and y is 0, because we set y equal to 0 to start off with. Y-intercept, we set x equal to 0. Solve for y. So very similar. Two times 0 in the first term is just 0. I get 3y is equal to 6, and so y is 2. Or equivalently, the ordered pair is 0, 2. Six. Oh, yeah. That should be a 0. Nah, I don't want to confuse anybody. So. If you say that's a B, I'm just going to ask you to leave. That's a joke. Okay. That's definitely a joke. Okay. So, wait, no, that should be 2. All right. See, Caitlin, you throw me off. 2. 0, 2. Am I good? I should be good now. Okay, so we found the x-intercept and the y-intercept, and part B might be hard to see, but it does say graph the equation. So it's easy to graph stuff when we know 2 points. Yeah, that's very fair. We know 2 points. The first point we found was 3, 0. So I boxed that in over here. The second point we found was 0, 2. And by plotting those 2 points alone, what the software will do is it will connect the points for you and generate the line. It should be fun. Not too bad. So it will create that line for you simply by virtue of plotting 2 points. Now, the good thing about doing all of this is if you have a graph, it's normally pretty easy to figure out the slope-intercept form. because you could use the point slope formula, and you would have to figure out the slope. We don't have the slope here. We do not know the slope in this problem. It is not written in slope. The original problem is not in slope-intercept form. In fact, it's in something called general form. You don't have to know that. The point is, we do not know the slope right now. Unless you look at the graph and you determine the slope from the graph. How do you use a graph of a line to determine the slope? We use rise over run. So that's the convenience of having this graph available. We can use rise over run. Or if you really want to, you can use y2 minus y1 over x2 minus x1, because we do have 2 points. Either one is acceptable. Let's see. In red, I'll emphasize the rise, which seems to be -2. And I'll use, say, blue for the run. That seems to be 1, 2, 3 units. So that would be rise over run. The rise is -2, the run is 3. And that's the slope. That's the convenience of having a graph. Now, so we're still figuring out the slope-intercept. We figured out the slope. Well, naturally, what comes next? The intercept, in particular, the y-intercept. Well, we have the graph, which tells us, in fact, we found the y-intercept up in part A. The y-intercept we found was 2. So here we could put all of that information together for part C. I'm just going to put that answer over here. We found the slope to be -2 over 3. And we found the y-intercept already to be +2. And this would be the slope-intercept form. Okay, so in-class people, any questions about this? Was that a question? Okay, Google Meet people. Yeah, this might be review for a lot of you, if so. And like I said, this section, if you skip around some of the problems, a lot of it may seem very much familiar. Slope stuff, intercept stuff. A lot of stuff that you probably learn in high school algebra. I don't know, do they teach Common Core now in high school? Is that a thing? Or I haven't been into high school in like 10 years. I don't know what they do now. What's that?
I said I went to private school. We didn't do Common Core.
Oh, private school. How fancy. At least you didn't go to Ponchatoula High School.
That one worse than that. We probably would never, I went to Fort Allen High School.
Oh, wow. I was talking about my brother. It was a while ago.
Let's go ahead and talk quickly about, I should be able to get through with parallel lines and example 5 in particular. So this is another characteristic of lines. So 2 lines are parallel. So I think we all know the idea of parallel, at least in a geometric fashion. 2 lines are parallel if they continue on forever in both directions and they never intersect. So that would be 2 parallel lines. I mean, generally the idea is like train tracks. And so, but how do we, so naturally we like to use geometric ideas and try to visualize how to figure them out algebraically. And so two lines are parallel, but they have the same slope. That's it. They have the same slope, they're parallel, because they both have the same trend or the same slant. So they have to have the same slope. I'll talk about the perpendicular one probably next time. I'm just going to focus on parallel. I have some extra time after this problem. I'll do that. But here they ask us, for example, 5, to find the equation of the line where this line is parallel to this other line. So to sort of dissect this, because I've had a few people, I think in previous semesters, people haven't understood this problem. So they give us this line. They already give us the equation for that line. So that line, there's nothing else to solve about that line. They tell us that that line is y is equal to 2x. All right, cool. So what about it? They want to know what the formula is for another line that's parallel to it. And they give that other line, I'm just going to overlay it in blue. So they want us to find the formula for that blue line that I just really shaded in to emphasize it. And they generously gave us a point on the line. But they want us to find the equation for that. And most likely point slope, or not point slope, slope intercept form. So we could, so to figure out the equation of a line, we need to know the slope and the intercept. Well, notice very generously here, since they gave us the graph, then we can figure out the slope. And, well, we can figure out all that information. We don't even have to do anything else, really. So if we look at this blue line here, well, if anything, we know that the slopes between this one and that the line that's in black have to be the same. So what is the slope of the original line? Well, hopefully you can recognize that this original line is in mx plus b form. It already is. And you might think, well, isn't there, where's the plus b? Technically right here. So here you get m is 2 and b is 0. B is 0. There we go. So why did I figure that out about a line we already know? Well, for two lines to be parallel, they have to have the same slope. They gave us the slope as 2. So for any parallel line, it has to have a slope of 2. So now for the blue line, we know that the slope is 2. Or you could have looked at the graph and probably figured it out as well. In any case, we know that the slope is 2. And we can definitely assume that very quickly by looking at the previous line. So all we need is the y-intercept. But they gave us, well, the graph. So we can figure out the y-intercept very quickly. It is right here. Because that's where the line crosses the y-axis. So what is that y-intercept? Seems to be 4. Because we want the y value. Just count up 1, 2, 3, 4. So we put all of that together. mx plus b is now 2x plus 4. Notice it has the same slope as the original line they gave and a different y-intercept. That would be our answer. Very patriotic color scheme, if I may add. But besides for that, I will talk about the perpendicular stuff on Wednesday. So this homework for this section is going to be due Thursday. That means you should start doing these problems for the stuff that you already know. You should already get started on that. Because I will finish this section on Wednesday, and then that homework will be due Thursday. So it is imperative that you get started through the problems that are manageable. Homework's due tonight, quiz tomorrow, next homework Thursday. Please start keeping track with all that stuff. In-class people, any questions about anything? Because if not, you're good to go. Google Meet people. If you don't have any questions, Google Meet people, you're free to go. I'll post the link after class.